So let's look now at this example coming from SS2 New General Mathematics of page 75, exercise 7b number 7. Is an example of simultaneous linear equation. So we have 1.5x minus 0.7y. This is equals to 0.1. We can call this equation 1. Then here I have 0.3x plus 1.1y equals to 2.5. This we call equation 2. So now what do we have? This one is in decimal form. So if it is in decimal form, we can work with it in the form it is. But I think it is better to convert it to something we are very familiar with. So we first of all put it in an improper fraction, or rather in a proper fraction. Then after that we put it back to whole number. So we transform as follows. So this could be equation 1 can be written as 15 over 10. You remember that if you have 1.5, then under the decimal point you have 1, then the next digit is 0. So at the end of the day, you have taken off the point, so you now have 15 over 10. So 1.5 is equals to 15 over 10. So that's why we're going to write 1.5 to be 15 over x, 15 over 10x. Then we have minus, then 0.7y is the same thing as 7 over 10y. Then 0.1 is the same thing as 1 over 10. In the second equation, maybe you call this equation, let's not label it, it's not important for now. Then the second equation, 0.3x could be written as 3 over 10x. Then plus 1.1y can be written as 11 over 10y. So we're putting this, some are in proper fraction, some are improper fraction. While we are converting it to fraction, that's what we're doing, moving from decimal to fraction. So here 2.5 is the same thing as 25 over 10. Then you now have a fraction, but luckily enough, the fractions are of 10. So here you have 10, 10, 10. So here you have also 10 as the denominator, 10 as the denominator, 10 as the denominator. So you find out that the LCM is 10. So you can multiply each of the equations by 10 in order to remove the fraction. So now, supposing you call this, maybe this is equation 3, and this is equation 4, for instance. So you multiply here by 10, multiply here by 10. So if that happens, you see that here is 15 over 10, or rather, 10 times 15 over 10 x minus 10 times 7 over 10y is equals to 10 times 1 over 10. Then the other equation is 10 times 3 over 10. Then plus 10 times 11 over 10 y equals to 10 times 25 over 10. So now everything is in whole number, because here this 10 will cancel 10, this 10 will cancel 10, this 10 will cancel 10, here this 10 will cancel 10, here this 10 cancel 10, here this 10 will cancel 10. Okay, so we are going to have, so in this equation now, we are going to have only 15x here, so you have 15x minus 7y, this is equals to 1. Then the second equation, we have 3x now, plus here, the only thing that remains is 11y. Here, what remains is 25. So this is equals to 25. So we call this one equation 5. Call this one equation 6. So now we have transformed this equation 1 and 2 to now 5 and 6. So we work with 5 and 6. At least now we have come back to what we are familiar with. But like I said initially, you can also work with it the raw the way it is, if you're able to manipulate the point. But if it will be difficult for you, you convert it to fractions. When you get to fractions, you multiply each of the equations by the LCM. Then you come back to the normal setting you are familiar with. So now this is the equation we are working with, equation 5 and 6 now. So you go by elimination. So now, suppose you want to eliminate x, then here is 15. You can also make here to be 15. If you allow here the way it is, allowing it the way it is just multiplying by 1. Then you multiply here by 5. Reason is that if you multiply here by 5, so that 5 times 3 makes here to be 15. So it will coincide with what you have there, so that you can now eliminate x. That is in the case of eliminating x. So what we will now say is therefore that we multiply equation 1. So equation 1, you allow it the way it is, that is multiplying by 1. Any number you multiply by 1 is that number. So multiplying equation 5 by 1 does not change anything. Then equation 6. So this is actually 5. Then equation 6, you multiply by 5 so that you can obtain 15 at 3x. So now the first the equation 5 you're multiplying by 1 means you still have the same thing. 15x minus 7y equals to 1. So there's no problem here. Then in equation 6 you're multiplying by 5. So 5 times 3x will give us 15x. Then 5 times 11y will give us 55y. Finally, here 5 times 25 will give us 125. So what next do we do to eliminate? You see that subtraction will go. Subtraction will work so that you have 15x minus 15x to be 0. That tells you have eliminated x. So if that happens, 15x minus 15x is 0. So that one is gone. Then here we have minus 7y minus 55y. So what are we going to have? That will give us 62y minus, because you have minus something. How? You have minus 7y. Then here you have your minus again. You have minus. Then here you have plus 7y. So you have plus 7y. Sorry, plus 55y. Then here is minus 7y. Then minus plus gives you minus. That's minus times plus gives you minus. So minus 55y. So that's why we're having minus 62y. I think we don't have problem with that. So that's what we have. So here we have minus on the right hand side. You have 1 minus 125 will give us minus 124. So what we are now left with is minus 62y is equals to minus 124. So what are we looking for now? We are looking for y. So we are dividing by the coefficient of y, which is minus 62. So here is minus 62. So here, minus divide minus is plus 62. Divide 62. You have only y left. Here, minus divide minus is plus. Then 62 divide here will give us 2. So what it means therefore is y is equals to 2. So now you have gotten y. The next thing to do is to go back and substitute y equals to 2 in any of the equation 5 or 6 in order to get the value of x. So we're now saying substitute y equals to 8. Sorry, y equals to 2. That's what we have in any of the equation. So let's say in equation 6, for instance. So the choice is ours. So suppose we say in equation 6. So it means that any place we see y, instead of writing y, we write 2 there. So in this equation 6, we have 3x there plus 11 times 2, because 2 is equals to y, equals to 25 on the right hand side. So you have 3x, 11 times 2 will give us 22. Then this is equals to 25. Then you collect like times, so you allow 3x to be here. Then 22 goes to the right hand side and becomes minus 22. So you now have 25 minus 22, and that will give us 3. Because we are looking for x, you divide both sides by 3. Divide here by 3, so that x divides 3x to give us x. 3 divides 3 to give us 1. So we can now say that x is equals to 1. So finally, we got x to be y, 1, and y to be equals to 2. So these are actually the two values we are looking for, x and y. And if you go back to the original equation to substitute x equals to 1 and y equals to 2 on the left hand side, definitely it will coincide with what you have on the right hand side.